Assalamualaikum and good day for everyone, especially to my beloved lecturer, Dr. Surya Binti Abdul Karim, and also my fellow friends. Today, my group will be presenting about the Flatiron buildings as the model for our geometry assignment. To fulfill the task, our group was chose the Flatiron buildings. It is because of that building has the characteristic of the geometry and is suitable for our research and our study about the geometry. The Flatiron building is originally the tallest building. It was located at 175 Fifth Avenue in the borough of Manhattan, New York City. The Flatiron building was designed by the Chicago's Daniel Burns as the vertical Renaissance palazzo with the beauty art styling, unlike the New York's early skyscraper, which took the forms of the tower rising from the lower and the blocky mass. The Flatiron building optimized the characteristic Greek columns and its stucco limestone at the bottom, changing the glazes terracotta. It is also considered to be the groundbreaking skyscraper. Upon the completion in 1902, it was one of the tallest buildings in the city. The building was designed a New York City landmark in 1966 and was added to the National Register of the Historic Places in 1979. After that, designed a National Historic Landmark in 1989. This means Flatiron building is one of the national official lists of the United States country historic buildings, district, site, structure, and also object of the preservation. Today, this building has become the most dramatic looking and its popularity with the photographer and artists. That's all from me. Thank you.
Assalamualaikum and a very good day everyone. I will continue the presentation about the location, size and also the usage or function of the Flatiron building. So for the first one is the location. The Flatiron building is a famous landmark of the central part of New York City, United States that's situated at 175 Fifth Avenue in Manhattan. This landmark stands on a triangular block formed by 5th Avenue, Broadway and East 22nd Street, with 23rd Street raising the triangle's northern peak. We can see clearly from the map that had been given. We proceed with the size of this building. The building size is 255,000 square feet in total. The height of Flatiron building is 285 feet, which is equal to 86.9 meter. While for the right triangle base, the Broadway front is 190 feet, equal to 57.9 meter wide. The 5th Avenue front is 173 feet, which is equal to 52.7 meter wide. And the 22nd Street side is 87 feet, equal to 26.5 meter wide. And lastly, I will explain about the usage or function of this iconic building. Initially, the building was intended to serve as offices for the George F. Ford Company. The Ford Company moved out of the building in 1929. Starting in the late 1990s, the continuing popularity of the building changed the neighborhood into a top destination for luxury restaurants, shopping, and sightseeing. Today, the Flatiron building is a popular spot for tourist photographs and is frequently used on television commercials, documentaries, and films. One of the films that featured Flatiron building is this film.
What you got for me today, New York? Reporting live from New York 1 chopper. An Oscorp truck carrying plutonium has been hijacked. A police chase is...
Apart from that, it is also a functioning office building which is currently the headquarters of various publishing companies, in addition to a few shops on the ground floor. That's all, thank you.
Okay, now I will explain all the geometrical shape of the object. Okay, for the first shape that are related to the Flatiron building is triangular prism. Okay, this is the first shape, is triangular prism. As we know, the shape of the Flatiron building is similar to triangular prism. Okay, as we know, prism consists of three shapes of the rectangle that join side by side and connected with two triangular bases. Okay, as you can see, this is the triangle, first triangle and second triangle, and this is the rectangle, first rectangle, second rectangle, and third rectangle. Okay, so in total, the triangular prism has 5 faces. The two triangular bases are parallel and congruent with each other. Okay, now we proceed with the second shape of the Flatiron building. As you can see, the side view of the Flatiron building is rectangle. Here, this is the rectangle shape, and in 2 dimensions, we can see this is the rectangle. Here, rectangle in 2D. Okay, as we saw earlier, the entire shape of the Flatiron building is in the prism shape. So that means the Flatiron building consists of 3 shapes of the rectangle. As we know, rectangle is a part of quadrilateral. That means it consists of 2 pairs of equal sides. Okay, the first side the equal is here, first, second, and the second pair is here, this one. We call as a length. This is a width and length. Okay, other than that, rectangle also consists of 4 angles of 90 degrees here, 90 degrees. 1, 2, 3, and 4.
From the figure, we can see that the top view of Flatiron building is a triangle. The base of the building is also a triangle. So, Flatiron building has two triangles. This is because a triangle is the union of three line segments that are determined by three non-collinear points. From the figure, we can see that the points are not lying in the same straight line. The top view also shows that there are three vertices. So, the top view of Flatiron building is a triangle. Geometrical concepts of prism. A prism composed of bases and lateral faces, where these bases and lateral faces are known collectively as the faces of the prism. Flatiron building is a triangular prism because it has two bases and three lateral faces. The two bases of the prism are triangle, while the lateral faces of the prism are rectangles. The bases are regular polygons because, by definition, a polygon is a closed plane figure whose sides are line segments that intersect only at the endpoints. Flatiron building is a regular prism because regular prism is a right prism whose bases are regular polygons. By theorem 9.1.1, the lateral area L of a prism with altitude h and the perimeter of the base P is given by L equal to h multiplied by P meter. You will get 11,940 meters squared. So the lateral area of Flatiron building is 11,940 meters squared. By using Heron's formula, S equal to half of A plus B plus C. So the area of the triangle of Flatiron building is 68.55 meters squared. The area of bases, so you will get 697.8 meters squared. So the area of the base of the Flatiron building is 697.8 meters squared. By theorem 9.1.2, the total area A of a prism with lateral area L and base area B is given by A equal to L plus 2B. So the total area of the base of Flatiron building is 13,309.6 meters squared. By theorem 9.1.3, the volume of a right prism is given by V equal to VH, where V is the area of the base and H is the length of the altitude. V equal to VH. So the volume of Flatiron building is 60,638.82 meter cubed.
Okay, now I will explain the geometrical concept of the rectangle. Okay, the length of the Flatiron building is approximately 285 feet or equal to 86.9 meter, and the width is 190 feet or equal to 57.9 meter. Okay, we recall the side of the Flatiron building is rectangle and is a part of quadrilateral. Refer to corollary 4.2.1. All angles of rectangle are right angle, congruent, and every opposite side are equal. So we want to calculate the rectangle using the formula perimeter, area, and diagonal. Okay, we continue with the first calculation, this perimeter. Okay, by definition, perimeter is the sum of the length of the edges. A rectangle has parallel sides of have the same length. The formula of perimeter is length plus width plus width. Okay, so here, this is the length and this is the width. And then we apply the value into the formula equal to 289.6 meter. Then we continue with the second calculation, the area. Okay, by definition, the area of the rectangle is the space covered by the shape. The formula for the area of a rectangle is length times width and equal to 5,031.5 meters squared. The line segment that join the opposite corner of a rectangle are known as a diagonal. A rectangle has two diagonals. Refer to corollary 4.2.2. The diagonal of a rectangle are congruent. That means they are equal in the length and intersect in the middle. Okay, in the given figure, the two diagonals of rectangle are RP, RP and SU. Here SU. The red line is the SU and the blue line is the RP. Therefore, RP equal to SU. To calculate the diagonal, we use our Pythagoras theorem. Okay, here this is the first Pythagoras. This leg is A and this leg is B. This is the right angle 90 degrees. So we want to calculate the D. This is the diagonal. You can say the formula is C equal to square root A squared plus B squared. Okay, we want to calculate the diagonal, so we use the Pythagoras. For instance, I choose this side of the R, U and T. The line is the diagonal. Okay, before that, we have to know the value of the leg. You see, UT is 86.9 meter and the UR or RU, the value is 57.9 meter. Okay, this is the formula. Because we want to find the RT, so we put here RT equal to square root RU squared plus TU squared. So and then we apply the value into the formula. So after we calculate, we get 104.1 meter.
Triangles can be classified by its congruent sides or by its angle. Congruent sides are two sides with the same measure. The side lengths of Flatiron building are approximately 87 feet, which is 26.5 meter. 190 feet, which is 57.9 meter, and 173 feet, which is 52.7 meter. If we classify the triangle with its congruent side, the top view of the Flatiron building is a scaling triangle because it does not have any congruent side. If we classify the triangle with its angle, it is a right angle triangle. It has only a right angle triangle. The Pythagorean theorem holds for the Flatiron building. The definition of Pythagorean theorem is the square of the length C of the hypotenuse of a right triangle is equals to the sum of squares of the length A and B of the legs of a right triangle. For example, A squared equal to B squared plus C squared. The hypotenuse, which is the longest side lengths of top view of Flatiron buildings, are approximately 57.9 meter. The other two sides are 26.5 meter and 52.7 meter. The sum of squares of the 26.5 meter and 52.7 meter gives 3,479.5 meter. The square root of 3,479.5 meters gives 58.9 meter, which is near to 57.9 meter. So this theorem proves that Flatiron building is a right angle triangle. There is a 90-degree angle in the top view of the triangle. The acute angles of the top view are 25 degree and 65 degree. The sum of the measure of the interior angles are 180 degree. This applies to the theorem 3.1.1, which states that in a triangle, the sum of the measure of interior angles is 180 degree. When we add up the acute angles, this applies to corollary 3.1.2, which states that the acute angles of right triangle are complementary. Each angle in the pair is known as the complement of other angle. We can also see that the measure of an angle is a unit positive number, postulate 1.3.8. By definition, the perimeter of a triangle is the sum of the length of its side. When we add up the side lengths of the triangle, it gives 137.1 meter. Thus, the perimeter of the top view of the triangle is 137.1 meter. Next, when we add up the side lengths of the triangle, it gives 84.4 meter. This applies to the theorem 3.2.2.5, which states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. This also proves that the length of any side of a triangle must lie between the sum and the difference of the length of the other two sides. A triangle is the simplest polygon. By definition, a polygon is a cross-plane figure with sides are line segments that intersect only at the endpoints. By definition, a convex polygon which the angle measures are between 0 degree and 180 degree. The top view of Flatiron building is a convex polygon. This is because each angle of the triangle are between 0 degree and 180 degree. By corollary 8.1.1, the area of right angle triangle is A equal to half of A multiplied by B. So the area of the triangle of Flatiron building is 698.3 meters square.
My name is Nur Anis Ayuni binti Mat Yusuf Azmi. So I will explain about the cross-section of Flatiron's building. For the cross-section, we will see from the two sides of view, which is from the side and the top of Flatiron buildings. For the side view, the Flatiron's building is in a rectangular shape. Rectangle is in a quadrilateral category. Flatiron buildings has two pair of equal sides and has four angles measured 90 degrees. All sides join together to form four right angles. The top view of Flatiron buildings is in a triangular shape, same goes to the base. Overall, the Flatiron buildings has two triangles. The union of three line segments that are determined by three nonlinear points. To sum up about the Flatiron buildings has a unique triangular shape and located at the intersection of the 5th Avenue and Broadway, New York City. Flatiron buildings was designed by Daniel Borahan and Frederick Gilbert. The name of Flatiron derives from its resemblance to a cast iron. Even though the Flatiron buildings is the oldest standing skyscraper in the Manhattan, the buildings is perfectly stable. It was the tallest buildings in the city upon its 1,902 competitions. The idea of the buildings is divided into three parts. The entire Flatiron buildings is generally triangular prism because it has two bases and lateral faces. The cross-section of the building's shape is a triangle from the top view and rectangle from the side view. From the top view, there were two triangles and rectangles from the side view. The balance of geometrical shape and width of the buildings makes the Flatiron's building stable.
As a conclusion, we can see how geometry is applied on the Flatiron building. Geometry plays a crucial role in design as well as construction. This can be shown when the design of Flatiron building, which is D.H. Burnham enveloping geometric designs, engraving the exterior, giving it an Italian Renaissance architecture feel of Biox arts. Geometry helps in deciding what materials to use, what design to make, and also plays a vital role in the construction process itself. The Flatiron building became one of the most recognized and a quintessential symbol of New York City because of its unique shape and prominent location. Even the whole neighborhood district was named after it as Flatiron District. It becomes an icon of New York City and a bustling district that is home to a vast variety of excellent dining and retail options. That's all. Thank you.